Welcome to the second section of the video course, R Troubleshooting Solutions. This section is on investigating new packages. The ecosystem of user-created packages is one of R's strongest features. However, it's common for our programmers to encounter situations where they can't quite get a package to work in the way they want it to. This might be because the package is poorly documented, because it contains a bug, or simply because the package author didn't anticipate it being used the way you want to use it. The two videos in this section are all about practical methods for dealing with packages that don't quite do what you want them to. We'll begin by learning how to investigate the objects produced by package functions, and in particular about the str function. In the second video, we'll look at the library and require functions, and how to use the double colon operator to remove ambiguity when calling functions provided by other packages. This video answers the question, how do I get data from an object? You'll learn about situations where a package might create an object that you don't quite understand, how to use the str function to investigate it, and how to extract useful values from an object. Let's move over into RStudio. In the source pane on the left side of the screen is some code for running a non-metric multidimensional scaling, or NMDS, a type of dimensional reduction technique commonly used in ecology. For the purposes of this video, you don't need to understand this method at all. Just note that we're using a package called vegan, which provides the meta-MDS function that we'll use to run the NMDS. Let's run this code now and see what it does. The meta-MDS function returns something which we've stored in a variable called NMDS. When we type NMDS into the console, we see some informative output describing the call that was used to create it, some information on the input data and the distance metric used, the number of dimensions in the resulting ordination, the ordination stress, and so on. But what is this NMDS variable? The information printed to the screen when we evaluate it doesn't look like a vector, or a data frame, or a matrix, or any other familiar base R data structure. So does NMDS just contain some text summarizing the ordination results? To investigate the object further, let's find out what data type it is using the typeOf function. TypeOf tells us that NMDS is a list. This might seem a little strange if you've seen lists in R before. Typically, when you evaluate a list, R will print to the screen each element of the list with either its name or its index as a subheading. But when we print NMDS to the screen, it doesn't look anything like a list, so we're no closer to understanding what NMDS really is. Let's run a different function on the NMDS variable that you might not have seen before, class. Now we're getting somewhere. Class tells us that NMDS is an object belonging to two classes, meta-MDS and mono-MDS. You might be familiar with object systems from previous programming experience. If not, a link will be provided in the notes for this video to an overview of the class system in R. Suffice it to say that the variable NMDS contains an object created with R's S3 object system. S3 objects are just lists with an additional class attribute attached to them, which we can see with the class function. Each class attached to an S3 object tells R that there exists a special set of functions called methods that are intended to work with objects of that class. Many S3 classes will be associated with a print method that determines how the content of an object will be printed to the screen if the object is evaluated by typing its name into the console. So, it's the print method associated with one of these classes of the NMDS object that causes this information that we see on the screen to be printed. We can confirm that the NMDS variable contains an S3 object using a special function from the prior, that's PRYR package called otype. As suspected, otype confirms that NMDS is an S3 object. So, now we know what NMDS is. Suppose we wanted to get some information out of this object. For example, we can see that there's a stress measurement associated with the NMDS object. What if we wanted to run 100 NMDS ordinations and record the stress measurement for each one? We could manually run the ordinations, print the resulting object, and write down the stress value for each one. But this would be a lot of work and would defeat the purpose of writing an R script in the first place. We could look at the documentation for the vegan package to see if there's a function designed to extract the stress value from the NMDS object. Unfortunately, in this case, there's no such function. So what are our options? Let's learn about one of the most useful tools for investigating mysterious objects like NMDS, the str function. str is short for structure, and its role is to expose the internal structure of an R object. It works for almost any R object, even simple data types like vectors and arrays. As you'll see from the second example, str provides some valuable information about the MT cars data frame, including the number of rows and columns, a list of the names and types of each column, and even the first few values in each column. Let's see what happens when we run str on the NMDS object. Suddenly, we have access to a wealth of information that we couldn't see before. We can see that NMDS is actually a list of 35 items. Remember that all S3 objects are fundamentally lists. We can even see the name, the type, and some of the contents of each element in the list. Some of these details appeared in the printed NMDS summary that we were able to see before, but some of them didn't. Recall that we're trying to extract the stress value from the NMDS object. We can see that one of the elements in the list is named stress and contains a single numerical value. What happens if we try to subset this element from the object, the same way we would for any base R list? And there we go. There's the stress value of the ordination. Now we have a simple programmatic way to extract the stress value from any NMDS object. This basic technique of exploring the substructure of an object with str, then extracting the values of interest by subsetting, is a powerful way to extract information from objects provided by packages, even if the package wasn't written with that kind of extraction in mind. Let's look at another example of using str and subsetting to extract data from an S3 object. This time we'll use an object created by the base R linear regression function lm, but exactly the same principles apply. We'll start by using lm to create a linear model out of the built-in empty cars dataset. We'll call it model. As before, when we print the contents of the model to screen, we see a neatly formatted text report, our first hint that we're dealing with an S3 object rather than a simple data structure. We can confirm as before that the model is indeed an S3 object, this time of the class lm. Let's suppose that we want a way to programmatically extract the y-intercept from the model. That's this value here. We can use str to expose the substructure of the model object. As expected, the model object is a list, and the very first element is named coefficients and appears to contain our intercept value. Let's use subsetting to extract the coefficients element. The coefficients element is itself a two-element atomic vector, so let's add a further named subsetting step to extract the single value that we're interested in, the y-intercept. And there we go. Now we have a programmatic way to extract a value that was previously not exposed to us.